Okay, first of all, yeah, your experiment, I guess, and I heard from people, I'm not sure, maybe electricity, okay, so, but anyway, just my guess, if something wrong somewhere, you also need to read properly the question, then follow the instruction, okay? So practical physics, first of all, thanks to this teacher Alina. Yeah, she compiled everything. Very good. So actually, this original set got 127 pages, but I feel no need. So because it include all of the experiment, so I just take out the electricity. Okay, so when you want to start your experiment, you need to check your apparatus from the first 5 minutes and read. Then I'm not sure how, maybe this year is guided or maybe unguided. Okay, what is guided? Guided means they give you diagram, they give you step 1 to step 6, then you just follow. Then what is unguided? They give you diagram, maybe the real diagram or not, then you write your step. Okay, so actually unguided also doesn't matter, just 4 sentences can make the procedure ready. Hi Aaron, they have given procedure, not given procedure. Sorry Aaron, I'm not sure what you're asking. They are given procedure, not given procedure. Yeah. Given procedure. Yeah, correct. Given the steps procedure or not given. So you write yourself. Okay, so hi. Okay, so but anyway, both needs you to identify variable. So if given procedure, follow instruction. So normally you need to identify your hypothesis, your MVRV-CV. But if unguided, normally they will just tell inference and you don't need identify MVRV-CV because they already gave. Just need to write down inference and hypothesis. So for guided, set up the apparatus. You just follow instruction. But for unguided, you have to set up by yourself by referring to the hypothesis stated. Means you need to write your procedure. Very good, Erin. Thank you. Okay, then tabulate the data. Just tabulate. Refer to the question given. Normally got 2 only, but sometimes got 3. So our MV in unit, RV in unit, then maybe they will ask you to calculate the R. If they don't, just MV, RV done. Tabulate data, you just same thing. For physics, most of the time, they require you to draw the table yourself. Okay? But I believe that you all from Form 4 to Form 5, luckily no MCO you all did many experiments and tabulate so many experiments already. So you all no problem one. Then plotting the graph, later I will tell that how to get full marks Full marks is 3. Hi, yes. Huh? What? Yeah, I can hear you. Huh? What happened? Xiao Hui, what happened? What do you want to ask? Or you accidentally on your mic? Okay, Xiao Hui. Oh, no problem. Oh, you accidentally on your mic. Never mind. Okay, so now the relationship of the variable from graph. Okay, from graph. Then normally got prediction or precaution steps. Okay, so now let's look at. Okay, so here are some precaution steps. If light, spring, electric, electronic, heat, ammeter, voltmeter, blah, 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 blah. Okay, anyway, here got a very universal precaution steps, which is we look at number 3 first, which is this one. Make sure our eyes perpendicular to the reading of ammeter and voltmeter to avoid parallax error. Parallax error means you cannot read properly. Okay, so for example, this is a ruler. So when our eyes look at the ruler, we must be perpendicular. 90 degrees. It's 90 degrees, not parallel. Because the light goes in a straight line, so here is 90 degrees. Right? So this is 90 degrees. To avoid parallax error means you take wrong reading because your eye position is not perpendicular. Alright? So you can just memorize this one. Every experiment can apply. Or if you can remember 2 more. One is make sure all the connections are correctly and tightly to ensure the current flow. Correctly and tightly means you clip on the metal pipe properly. Okay, then switch off the circuit after taking the reading to avoid overheating of the wire, to avoid the resistance increase. So switch off the circuit. If got switch, you just open the switch. If no switch, you just unplug any side. Unplug any side. Because if the current keep flowing inside the apparatus or wire, it will produce heat. Okay. Okay, so got part 1, 2, 3, 4. We can directly start from here. Okay, so for example, this one is normally is guided. Okay, guided. So normally they give you this, then you connect everything, and then normally they don't give this. This is your experiment result. Okay, just refer to experiment result. Okay, so from the experiment above, identify MV, RV, CV. So we can say that we need to read the question first. So the keywords: investigation of relationship between length of wire and resistance R. Okay. So since they already tell you relationship, so this is length of wire RV and resistance. Okay, sorry, I'm sorry. Now you need to think about is length of wire depends on resistance or resistance depends on length of wire. Which one? Yeah, is R depends on length. So depends on this. So L is MV lah, manipulated variable. R is RV lah, responding variable. Yeah, correct, Aaron. Very good. Okay, MV, RV, CV lah. So length responding variable would be resistance. Constant variable would be something. Then tabulate your data. Okay, so normally they tabulate your data 3 to 4 marks. Most of the time 3 marks only. But never mind. So now, for all the value of L, V, R, and I will make it fixed 0.5. Okay. So normally we make the table like this. L in cm, V in volts, R is rest. Normally we write I first. I is 0.2. I no need, sorry, I no need. Every time we fix I equals to 0.5. So R in ohm. So once you get V, since R equals to V divided by I, we use all of the V divided by I, you get R. Okay, but I don't think this experiment come out. Just guide you all. Read the question. Okay, from the questions you know what is MVRV. Read, huh? Okay, so now next, let's look at this page. This is page 12. Okay, so normally MV, RV, CV. Okay, let's say this is the heat load. Okay, so now I have a question. Teacher, will they be asking us to use jockey? If so, how do we operate the jockey? Jockey actually is like a crocodile clip only. It's like a crocodile clip only. But I tell you what, jockey now very expensive because whole thing made up by cotton. Whole thing made up by copper. If we buy this, we can buy a lot of crocodile clip already. So the jockey actually can treat it as crocodile clip. Just touch here, then see here. Okay. I don't think they got jockey. Too expensive. Yeah, so you can use this as a type. Too expensive. So they might use something to replace lah. Okay, now before I proceed to the setup, I want to ask about, can I say okay, can I say for example this, can I say the reading of thermometer? But this is just an example. I guess it's about electricity. Can I say this as my manipulated variable? Can you please answer yes or no? How many of you think this is suitable? How many of you think this is not suitable? Darren, thank you. And this rating of thermometer, yes or no? Okay, Darren, Hui, Chao Hui, Rene, yeah, not suitable. Answer, yeah, not suitable. Not, answer is no, not suitable. Why? Because reading is not a physical quantity. Okay. For example, reading of stopwatch is not a physical quantity. A physical quantity, for example, time. Time we say t equals to how the number n in second or in minutes. But reading is not physical quantity. All right. So remember, don't use reading as MV/RV/CV. Variable means physical quantity. Okay. So now let's look at the tabulation of data. For example, first mark we will give to physical quantity and unit. So let's say physical quantity T with unit, physical quantity with unit, physical quantity with unit. All three got physical quantity and unit, then we give you 1 mark. Must be all, huh? Let's say you write T in minutes. Forgot the last. Sorry, 1 mark missing. Okay. Then second mark, reading of your RV. Reading of your RV, or you minus it. Okay. You minus it. Then all correct. Then and also when time increases, this increases, follow your hypothesis. Okay, second mark. Okay, then what is the third mark? Wow, third mark, I tell you, very easy, but also very easy to get, but also very easy to lose. So, for example, let's say you got 2.4, let's say 4.5, 6, 8.3, 10.7, something. See, 6 only, no point something. So what you should do is, if you leave it like that, then you lost the consistency. So you must make sure, even though 0 also, you also need to add 1 decimal. Consistency means if you got 1 decimal, all got 1 decimal. If don't have, all don't have. All right? Yeah, thank you, Aaron. Yeah, very good. So even though 6 point nothing, you must write 6.0 to show consistency. If not, you lost 1 mark. Very kasihan. Alright. So actually, very easy to score. Make sure all physical quantity and unit given. Make sure your MV, RV, CV, you just follow your experiment result. Then last, you check if they have decimal, all got decimal or not. That's it. Okay. Then now, let's look at the graph here. Let's look at the graph here. I can say most of the experiment is a linear graph. also got curve graph. There are two curve graphs. Alright. Never mind. We look at this graph first. How do we count? Normally, graph also got 3 marks. 1 to 2 ticks, 1 mark. You get 3 to 5 ticks, 2 marks. 6 to 7 ticks, 3 marks. Sorry. So, for example, you lost 1 mark here. Oh, sorry, you lost 1 tick here. You still get 3 marks. Alright. So, if for example, let's say your results wrong. If you find out, my result wrong, can you still get marks in your graph paper? Answer is yes. As long as you draw based on your result. Wrong doesn't matter. Okay, why like that? Because we are testing your technique on drawing graph. Okay? Testing your technique on drawing graph. We are experiment result wrong, never mind. We are testing your technique on drawing graph. Alright, so now how to get technique correctly? Number 1, physical quantity and unit for x-axis. This is y-axis, and for your x-axis, correct. You follow your instruction or from the question. Okay, x, y axis both correct. You get 1 tick. Oh, sorry. Sorry. Number 1 is physical quantity for x, y axis. Physical quantity for x, y axis. X, y axis are correct. Then, you forgot unit for y axis. Sorry lah. So second thing cross lah. So make sure you have unit on both x, y axis lah. Unit. For this one, no need SI unit, doesn't matter. Because when we draw graph, we use the suitable unit. If we make it in SI unit, it will be very large number. Right? Just follow your experiment. Then, third tick is your x-axis. Third tick is your x-axis. XY axis is your scale even scale. Okay, start with 0. Do we need to write MV against RV on the graph? Actually, it's RV against MV. Normally they would write for you lah. But yeah, the graph actually not counted in marks. But it's a proper procedure. Graph of delta theta against time is y against x. Y against x. The name. We don't count the name for the marks, but it is a proper things. If you want to draw a graph, must write the topic. Yeah, the title of the graph. Okay, but normally they write for you. If not, hi Jonathan. Okay, so mark number 3 is, do you have even scale? Hi Jonathan, I can see you all. Do you want to show me your face? Don't worry, I recorded already. If you are not able to attend the class now, you can watch the video. Okay, so now even scale. Even scale means what? Means you start from 1, 2, 3. then 2, 4, 6. Okay, no problem. Okay, but you cannot make it as 3, 3, 6, 9, 12, or 7 something, no. Because 3 is an odd number. Odd number divided by 10, you will get 10 grid here, you will get 1 grid is 0.3. Actually, it's hard to calculate because this is even number. So, so even number is better. But unless one, let's say you want to say 5, 10, 15, can or not? Can. Because this multiple, this is 10 ma. So multiple of 10 or factor of 10 can. Okay. So 3 is not multiple for 10, so cannot. Okay, so since this is 10, so your multiple and factor for 10, right? So let's say your experiment, you start to plot at 3. You start at plot at 3. Sorry. Your experiment start to plot at 4. Can I put 4 here? 4, 5, 6, 7, 8. Can I? Can I start with 4? Our experiment start from 4. Can I make it 4? Can I? Yes or no? I start 4. 4, 5, 6. Yeah, answer. Thank you, Darren. Thank you, Isol. No one. Yeah, answer is no. No. We need to count the difference between two readings first. These two, the difference is 1. But we start from 0. From 0 to 4 is 4. Can you see that? Can you see that? So we say this scale is not even. So 4, 1, 1, 1, mana ada even? Mana ada balance? No. So is you should start from 1, 1, 1, 1. The difference all must be the same. 1, 1, 1, 1, 1. Alright? So like this, 2, 2, 2, 2, 2. Okay. So tick number 3. Tick number 4 and number 5. Number 4 and number 5 is you plot all 5 correctly. You plot all 5 correctly. So if you plot 3 correctly, so you only get 1 tick lah. So that's why if you feel, oh, your data wrong, but it's still plot based on your data, you still get 4 and 5 because we are testing your skill on drawing graph. Doesn't matter. Okay. So then number 6 is best fit line. Best fit line. If you can get this, congratulations. Very good. Very good. If you cannot get, for example, you get like this. Okay. So here I draw 3 lines. Your data like this. This is A. Yeah. Do you think A is best fit line? Yes or no? Yeah, no. Do you think B is best fit line? No. So, do you think C is best fit line? Yes. Even though no, even though it does not pass any data, but it's balanced. Can you see that? It's balanced. So best fit means the balanced graph. Best fit means the balanced graph. But normally you will get something like this. You will get something like this. Maybe you can cross two dots. Then after that you can see lah, two up, one down. Okay, let's still consider best fit line. Okay, the best fit line, tick number 6. Then number 7 is your graph. Graph means the green line. Graph means the green line must be over half of your graph paper. So please draw as big as possible, right? Makes your scale can extend as large as possible. I encourage you over 3/4 of the graph paper. So your graph paper so big, but you only draw so small. Sorry lah. Tick number 7, you lost it. In short, draw the line to fit the whole paper. Yeah, can say. Draw the line and make your scale can extend for whole paper. Like you zoom in. Very good. Okay, so now we count it. Normally when we mark in school we won't take so many things. We just look at you. Do you have cross? 1 cross minus 1 day. 1 cross minus 1 day. And then if you got 2 cross, sure you 2 marks already. Yeah. Okay, normally when we mark in school, we won't take so many, take 7 days. But in SPM, yes, they will mark based on it. Okay, so now draw graph, okay? Okay, so now let's see. This is the gradient. Okay, we look at setup first. Okay, look at setup first. Okay, set up this one. Okay, since it is electricity experiment, sure for voltmeter and ammeter. So be careful lah. Okay, our school, if we buy new one, normally we buy this lah. If you still got old type voltmeter, we got this. Okay, so be careful about the scale. How to find out the smaller scale? The accuracy or sensitivity. So we use 0 to 1 means 1 minus 0 divided by 10 division. So we will get 0.1 volt lah. This one you can see sometimes they got 3 negative 5 volts and actually this is 15 volts. So you don't connect to 15 volts lah. So we use 5 volts. Yes, normally our battery 1 is 1.5, 2 is 3, 3 volt. 3 also 4.5, so normally 5 volts is enough. So 5 volts is at the bottom. So we look at 0 to 1, 1 minus 0 divided by 10 division. Still the same, 0.1 volt, right? Then, oh yeah, one more thing is, normally behind got mirror. So you make sure you adjust your eye position, make sure you don't see, you cannot see shadow, reflection. Cannot see reflection of the pointer, Okay, if you see pointer got reflection on the mirror, 你可以看到镜子里面有那个针两个啊 ，sorry，不要。You adjust your eyes until you cannot see reflection. Then I guarantee you are perpendicular 啦 90 degrees 啊。Right, M method. Now let's see. Here is 0.2 minus 0 divided by 10. So you get 0.02. Then this one is the same. 0.2 divided by 10, 0.02. If you can see the image of the pointer, your eyes is not perpendicular to the measurement. Yeah, very good. Very good, Darren. Very good. Okay, I cannot copy paste. Copy paste. Yeah, very good, Darren. So now know how to get the sensitivity, huh? Just minus and divide how many division. Okay, you will get the connection for crocodile clip and banana clip. But I think our school all are crocodile clip. Okay. I think I'm not sure. Most lah. Okay, banana clip. Okay, so when you connect using crocodile clip, when you see this, make sure you open up, you click on the metal partner. Okay, like this is very good. This one, they put some wire outside connected, easy to clip lah. But if not, this is plastic. The black and red is plastic. Black and red is plastic. So make sure you twist it up, then clip on the metal part. Clip on the metal part. Okay, then if after you clip, the pointer move to the left, how do you do? Just exchange only, no problem. The scary part is it doesn't move. Okay. So battery holder like this. But our school battery holder, I believe all of you got explore before. Normally got 4. Normally got 4 slot. Okay, got 4 slot. And normally this one might be positive, this one might be negative. Got 2 types lah. Just read and put on your battery lah. So let's say if we use 2 battery, normally it's like this. You will got 5 connection here. So number 1 is positive and negative. Then for first one is first battery. For second one is second battery. So if you use 2 battery, directly you clip on the second one. Right? If 4 battery, you directly clip on the third one. Okay. Then banana clip, very easy. Just slot in. Just move it in like that lah. Banana clip. Okay, then next reels. I think I want to tell about battery first. Okay, battery like this. If this is black, this is negative lah. This is red, this is positive lah. Okay, so make sure your kedudukan terminal must be sambung dengan betul. Means this is positive, so please put like that, positive. Okay, then normally the spring is negative now. Normally the spring is negative. You just read like you can see here. You can see here this is positive, this is negative. So you just observe yourself, see properly, then you put it in. Okay, then like this also cannot, this is not tight. Cross means not tight. Okay, make sure you make it tight. And then sometimes when you put it in, you will not notice this spring have not good elastic potential energy, so it will not come back. So make sure you push. Make sure you use your finger. Make sure you use your thumb. Push it. Push it from the spring side towards the positive another side. Push. So that this one will be tight. Now sometimes if you find out, no current, no. So maybe it's a problem of this. You just press first. Okay, just press first. Because sometimes the coil, the spring is not returned. So make sure you push. This is very important skill. Okay, so be careful about the crocodile clip. Must clip on the metal part. So if you clip on the plastic part, you will not get any reading tool. Okay, so you can see first one is 1.5, second one is 3.0. Make sure you click on here only. Okay, then we look back to rheostat. So the rheostat in this experiment actually is used to control current I. Okay, then how to control the current? Make sure you one click up, another click to the opposite down. Understand? Up and down, one up, one down to the opposite. Okay, for example, if you clip both down, this is fixed resistance, okay? So this one cross. Okay, make sure you clip one up and one down. Right? Yeah, then like this, you adjust the rheostat. If we say adjust the rheostat, is we slide the rheostat. Then we can see the changes of I and V. Okay, some rheostat got two sides up, two sides down. So you want to connect this side and opposite downside, I also can. Just remember one up, one down. Okay. Now, so like this, one up, opposite down. Then when you slide your rheostat, you will get different current. Okay, that's why in Form 3, when we learn Ohm's law, we are using battery. V increases, I increases. But in Form 4, Form 5, we learn Ohm's law is I is here, V is here. Then when we get the graph, we will get the gradient. So gradient actually is the changes of V divided by changes of I by 2 resistance. So in Form 4, Form 5, we are using current as our x-axis, then voltage for our y-axis. Alright, so we don't use this anymore. Because Form 3, we just let you have the idea. But when we practice in Form 5, yeah, we must follow the follow the real experiment. Okay, so now look at so here are Ohm's law and factor effects resistance but I guess maybe it's EMF. Maybe it's Ohm's law and non-Ohm's law. I guess. My guess only. I don't know. If I know, then I will go. I need to be locked up already. I don't know. The exam paper will be the exam paper are already sealed, and then only that day we can open and know the experiment. And I will do experiment with you all together on the same time, but in another room. Okay, then I'll try to make, since we got 3 sit down, I'll try to make three sets of different experiments. Okay, so let's say you need to draw the apparatus. Please label, alright? V voltmeter, A ammeter, rheostat, battery, then this is connecting wire. Okay, so for example, this is unguided experiment. They will tell you turn on like this, then they ask you to draw what? So suitable inference. What is inference? This is the formula. It will be RV depends on MV. This one, since this one no rheostat. So we are using different dry cells. So for this case, it's RV depends on MV. So we say suitable hypothesis. Hypothesis is we can say our MV increases, RV increases too. So this is the format if they ask for inference and hypothesis. And for example, your pendulum. Inference pendulum is length of pendulum. Right, time period for pendulum depends on the length. So we say period depends on length. So hypothesis is length increases, period increases. Okay, so this is the format. Okay, so very easy as long as you know MV, RV format of the. Okay, so arrangement of the apparatus, you just not draw back is by using apparatus given, plan an experiment to investigate the hypothesis. The hypothesis is current increases, potential difference decreases. This is Ohm's law, okay? So we can say this law. So we arrange everything. Don't forget to add your rheostat. Okay, that day I heard someone ask me, teacher, would it be battery provided? Of course lah, electricity mana boleh tak ada battery, right? No man, it's impossible. Maybe you can use the love to generate electricity. No, we use battery in science. All right, now procedure. Example of arrangement of apparatus. When you set up, actually, I advise you So remember, all of this cannot be if we are receiving a reading of value of amount of type of material cannot. Material for the wire cannot. Size, pattern, or cannot. The size actually can describe more properly like length, like area, like volume. So don't use size. Okay, so we look at non-ohmic law first. Non-ohmic law means it's a bulk. The bulk made up by filament. Oh wow, it's raining outside. So this one, Ohmic's law means the graph is linear graph. But non-ohmic law means the graph is a curved line. The graph is a curved line. Understand? Okay, so we say carry out experiment by using step below. So this is guided lah. If unguided, how do you draw a line of best fit for a curved graph? Okay, let's look at the curved graph. Like this. See, we always use graph V against I. V against I, right? This is not the best lah. Let me show you. I asked from friend. My classmate. Nah, like that. Hey, why cannot? Why cannot? Why cannot open? Why cannot open? Wait, why cannot open? This one. Something like this lah. So when you draw it up already, then you draw your gradient. You draw your gradient based on the straight line. Something like that. Okay. Based on this is curved line. So we use this part as our gradient. Straight line tangent to the curve. Yes, correct. So this is our gradient. M equals to dy over dx. Gradient. Oh, we use dy dx not. Actually, I lazy to say. I lazy to write. Y2 minus y1 divided by x2 minus x1. Actually, this is the same thing as changes of y divided by changes of x. So I lazy write this, I write this. My meaning is, yeah, still y2 minus y1. Still y2 minus y1. Yes, just changes of y. So once you draw the gradient, please write this is your x2, y2, let's say somewhere here is about your x1, y1. And you use y2 minus y1 divided by x2 over, divided by x2 minus x1. Okay, then I see I can look this one more. Right. Later I send to your class. Send to your class. Okay, so like this. Okay, now how to make a curved line? You can buy the curvy ruler, or actually I like to draw by using freehand. Okay, so when your paper like this, you just makes your hand have the momentum and inertia first. You just practice how to say that. 你这样子虚虚这样画过去。You mix your eyes and your hand. Okay, don't fix your hand in the table because it's a very big line. You draw. You make the curve. If you feel the curve perfect already, you just draw up. Only one line. Don't draw like that. If you draw like that, the best fit corner. Okay, just one line. All right. For me, I will practice like this. Come back. Come back. Just follow. Make sure you practice until you get the momentum and inertia. You want to draw from top also can. Top to the bottom. Top to the bottom. Top to the bottom. Okay, top to the bottom. Something like this. And you find out, this part not so good. I rub and redraw. I cannot like that. You rub all. But don't erase out your plot line, okay? And you erase all. You do it again. This one better, something like. Okay, so you have two choices. One is by the ruler, can curve on. Second, freehand. But I believe that you all draw so many graphs in maths and MS. This is actually a quadratic graph. So I believe you all got the technique already lah. Just when you draw gradient, you follow this part. No? When you draw gradient, you follow this part. You follow this part like that. No? You follow this part. You can see the triangle. Something like. Okay, so once you draw your gradient, use the point on the gradient. For example, this point. Now make sure you draw triangle. Make sure you got this triangle. When you got this triangle, and maybe you can, okay, once you draw this triangle, you can use this point also, doesn't matter, even though no touching the graph doesn't matter. So this is x1, y1, this is x2, y2. So what happened? So once you draw triangle, you get one thing for your gradient, all right? For the gradient value, what is the range usually like? Plus minus 0.1. I advise you 3 decimal, 0.001. Follow AppMath lah. So AppMath actually wants 4 decimal. At least 3 You want to make 4 also doesn't matter. More decimal means more accurate. Okay. Thank you, Jonathan. Yeah, very good. Okay, so the same thing most of the time is V against I. And you can see actually this one starts to plot on 0.1. Then you look at your next reading. Next reading is 0.12. So what is the difference? 0.02. Means you need to start from 0.02. Understand? If you don't know what to start first, you minus first. The difference 0.02, start 0.02 until 0.1. Then only you start to plot. Don't start with 0.1, 0.12, 0.14. Cannot, huh? If you start with 0.1 first, means 0.1 is your difference. Then next 0.02 is your difference, 0.02. So this scale is not even. Then you lost one tick. Okay. So total got 7 tick, 6 to 7 tick, 3 marks. 3 to 5 ticks, 2 marks. 1 to 2 tick, 1 mark. So we are testing your drawing skill. We are testing your drawing skill. Okay, it doesn't matter if you have wrong results or not. Okay, I feel this is possible. Just my opinion. Okay, you read properly. Okay, so now I encourage you to connect the apparatus. You connect the series apparatus first. Oh no, something wrong somewhere. Okay, doesn't matter. Okay, so first of all, you put your apparatus like this, battery, bulb. Okay, voltmeter always parallel, so we connect the series first. Connect the series first. Okay, black wire or red wire doesn't matter. They all are wire lah. Okay, they are wire lah. So I encourage you to make the ammeter face to you. Even though you put like this, but face to you. And then the rheostat, if you are right-handed, you can put on left-hand side. If you are up to you. As long as you're easy to adjust, to slide the rheostat. Okay, so why put the ammeter and voltmeter face to your side? So that you're easy to see. Okay, you're easy to see. So connect series first. Voltmeter always parallel, so like that. Okay, so the light bulb normally got light bulb holder, and here is the screw. Here is the screw. Okay, here is the screw. So for this case, they make another wire out, so you just clip on it. If don't have, maybe we can click on the screw. Okay, but when you clip, you clip properly. If not, it's easy to disconnect. Okay, then how to make Okay, how to make, so you can see this diagram. So for example, if how to make parallel. So parallel across the light bulb. So like this lah. When you click like this already, in between actually got space. So you click like this, perpendicular to crocodile clip. You click perpendicular like this, perpendicular like this. Okay. Our lab already closed for getting ready of the real exam, so sorry that I cannot bring you all to do. Okay, so you click like this or like this. Okay, so make sure you series first, then finally parallel. Okay, then one scary thing is you set up everything, then no current. First, check, is your battery holder? Actually, I advise you the first 5 minutes after check all of the apparatus already, then you read first. You read everything. You read procedure or what. Then if you have time, then you can start to check lah. Like battery directly connect to ammeter. Is the ammeter pointer deflect? Battery directly connected to voltmeter. Is voltmeter deflect? Battery connected to rheostat and to the light bulb. And when you slide, this light become dim or brighter or not lah. Or maybe, maybe rheostat directly to the ammeter and to the battery. Battery, ammeter, rheostat. One up, one down. Then when you slide this, will they move or not? Okay, so there are this time is unguided or guided. Mana saya tahu? If I know, I already look up, right? Color of wire doesn't matter. Yeah, color of wire doesn't matter. Red or black. Everything is just my friend guess and my guess. I don't know. If I know, I can look up. So I just try to guide you. Okay, so apply to. Okay, number 1. If your set doesn't work out, maybe got 3 possible problem. Number 1, your battery. All of you got new battery lah. Okay, I think. Okay, number 1, battery. And do you push it? Here got spring, correct? Here got spring. When you put it in, sometimes the spring doesn't return. So make sure you push forward to another side. From the spring, push to another side. Make sure they are tightly connected. They are tightly connected. Okay, they are tightly connected. So then, if tightly connect and then when you connect to ammeter, it works. Then maybe you can try to check wire one by one. Check wire one by one. So two, we got a few lah, two lah. Every time check two. I think at least 10 only lah. Sorry, maximum 10 only lah. Depends, I think all of you did this before. So just check lah. Okay, you check emitter, then directly you connect it to rheostat. Then you check voltmeter, then you check light bulb, like that only. I think within one to 2 minutes can check all already lah. Then you pasang again lah. I encourage you to put properly first, and you just follow series circuit and parallel circuit. Okay. If guided, okay lah, very good lah. Unguided, okay, I'm going to teach you how to write steps for unguided. Non-ohmics law, normally we don't do lah. But now, so you can read lah. But EMF we did, so you can read the EMF also. Okay, so now look at this electricity. So let's say you need to connect like that. So put battery holder, switch, ammeter, bulb, rheostat, connect series first. And finally you connect voltmeter. Alright. Voltmeter parallel, so last, okay, you make series circuit first. Series circuit. Alright, so now, okay, how to write the steps? Normally, sentence number 1, you write, arrange the apparatus given as shown in the diagram above. So you draw already. You draw yourself, or you say as shown in the diagram above lah. Then number 2, close switch, adjust the rheostat to set current flow to 0.1 ampere. Okay, so this is your MV. You need to close switch first so that the current flows out. Adjust the rheostat, means you slide the rheostat lah, to set current flow I equals to 0.10 ampere. Your first MV must have a reading like this. Must give a number, yeah. Must be a specific number, 0.10, all right? And then, don't use this sentence, record the ammeter and voltmeter reading. No. Okay, so you can say adjust the rheostat of setting current flow I equals to 0.1 ampere by using ammeter. Okay, so current is your MV. You set a number by using what? Then, next what to do? You say measure. It's a must to use measure. Voltage or potential difference. Measure and record potential difference by using voltmeter. Okay, this is your RV. Measure the RV by using voltmeter. Shall we write in active voice or passive voice? Both also can. Active, passive, both also can. But active lah, active, because this is not your report. It's your report too. But never mind. This is active voice. Last time, yes. Last time when I study, yes, they require passive voice. But this one active passive you can. Okay, measure and record potential difference by using voltmeter. What apparatus measure what? You must tell. Then repeat the step with current. You can see 1, 2, 3, 4, and originally 5. 1, 2, 3, 4, 5. So you must have at least 5 manipulated variables. Okay. If unguided, so how do we count the marks? Number 1, this one arrange no mark, but you must write. Okay, then continue to here, MV. Adjust by using ammeter. Your MV, adjust your MV with a number by using ammeter. Mark 1. Measure and record your RV means potential difference by using voltmeter. Second mark. Repeat the step with 4 MV plus 1 MV on top. You got 5 MV, another mark. If you just say repeat step 1 with repeat step 2 for several times. For several times. Sorry, no mark. You must tell properly what is the proper number you use. For a few times, no marks. So from here, you must have 5 manipulated variables. So you got 5 responding variables. This is how we plot the graph. Okay. So if this is a light bulb, then sure our graph is curved. So make a curved line. So this is light bulb. This is EMF, same thing. Okay. If EMF, make sure you extrapolate because y-intercept is 1.5 volts. Y-intercept is EMF, right? So this two you read properly. If it's unguided and we have to write our own MV, what is the max current we can put? Depends on your ammeter. Depends on your ammeter. Normally is 1 ampere maximum. Depends on your ammeter. Normally 1 ampere is the maximum. So if okay, you can do your first MV 0.2, 0.4, 0.6, 0.8, 1.0. Remember, 1 decimal, 1.0. Okay, if you cannot get, if you slide, you adjust your rheostat. Cannot reach 1.0, how? Okay, let's say maximum up to 0.6. Then you can start with 0.1, 0.2, 0.3, 0.4, 0.5. As long as you have 5 manipulated variables. But normally can reach 1. Okay, you cannot, if unguided, you can decide yourself. Okay. Okay, can 2, 4, 6, 8, 1, can 1, 2, 3, 4, 5, can 2, 3, 4, 5, 6, no problem, as long as 5 manipulated arrow. But this time our school get ready for everything, okay? Everything but new things, so I believe no problem. So when you feel not working, check battery first. Is it tight? Push it. Is it tight? Check every apparatus working or not. If every apparatus working, but once you connect, I still no current. How? Check. Are you clipping on the metal part or the plastic part? You want to put crocodile clip like that also can, but I encourage you to twist it up, then you connect to the metal part. If everything you check already still cannot work, I raise hand. May I change apparatus? Can, but you check all first. Okay, you check all first. Am I allowed to connect the ammeter and voltmeter straight away to check if it can deflect? Can, no problem. Can connect directly. Can during the preparation phase can. Connect directly, then you will see is it moving. But don't worry, really we bought all new. And lab assistant check all. But still, they are sensitive. All of the E&E, electric and electronic, they are sensitive. Yeah, so they might not function on the day. Might. So if you check everything, still cannot. Okay lah. May I change? Okay. Check everything first. Don't simply say I want to change. 2 years ago, your senior, many people change many things. So we all kelam kabut. Because the teacher invigilate you in the science lab is other school teacher. So some, they are language teacher, they are semi teacher, they don't know about this, so they kelam kabut. So you check first. You check. 2021 also we use all of the wire. 2021. So check what? Number 1, battery tight or not. Number 2, ammeter, voltmeter, rheostat all working or not. Number 3, check wire, every wire working or not. Yeah, directly connect to ammeter, then check your wire. Okay, so check all, still cannot change. But maybe after you check these 3, maybe one wire not working, then change this wire only. Okay, can connect directly, no problem. Okay. But when you use voltmeter, normally we use 5 volts. Okay, 5 volts. So you will see lah. Okay, one. Okay, so the rest actually not so important. Okay, so I guess my guess only maybe EMF, maybe non or mixed flow. I'm not sure, really not sure. If I know already, I will go look up. I will be arrested. Yeah, I don't know, really don't know. Just my guess, my friend guess. My friend also at physics teacher. Not so sure. Okay. Then here, okay, if you feel, the step, how, you can refer here. Okay. You can refer here. And then this one, the precaution step, remember, at least remember one. Then all of this you can use for your paper too lah. Okay, you can use for your paper too. Okay, then the prediction. Prediction, for example, EMF. Formula is what? Formula is E equals to B plus IR. Okay. So they might ask, if I increase voltage, what will happen to the EMF? Actually, EMF decrease because this plus this one. So when you increase this, you decrease. Sorry, the EMF actually, no, sorry, they should ask for current or what. Okay, the prediction. Just follow the formula lah. Okay, then the last, electricity. So normally the graph for ohmic law is like this straight line. For non-ohmic law, is curve. For EMF is straight line down. Okay, so but all you can see is V against I, V against I, V against I. Okay. Okay, yeah, the last relationship from the graph. From the graph. So for this case, relationship from the graph is V is directly proportional to I. Because you already draw graph means you can analyze, you can assure, you can confirm their relationship already. So yes, directly proportional. This one is V decreases linearly. Linearly means straight down, straight line up. Decreases linearly to I. Can you write V and I only? Can. But you cannot say this, V increases, I increases. I cannot have this is hypothesis only. Means you guess. You are not sure how much it will increase, decrease. But after you draw graph, you can know how much already. So this one, if you say V increases, I decreases, sorry, no. Must use your maths knowledge to tell the relationship. And how about this if it is a curve graph? So we say V increases with increasing rate to I. Upper to increasing rate. Okay, it's like this. If you draw 3 dots here, you draw a grade, you determine the gradient here. You will find out it is not increasing linearly. It is increasing with increasing gradient. Increasing gradient means increasing rate. Increasing gradient means increasing rate to the up. All right? For this one, this one we don't have that. We don't have in our experiment. But in your math, yes. In this one, we make 3 gradient. We'll find out, the gradient decreases. So let's say this is y, this is x. So we say y increasing with decreasing rate. Rate means your gradient to x. Okay, rate means your gradient. Increasing gradient to I. For relationship, if they say from the graph, from the graph. You need to tell directly, decreases linearly, or increase with increasing rate to 100. Okay. Okay, so I think that's all. Any other question? Okay, if no question, wish you good luck lah. Okay, and by the way, just 15 marks lah. Just try your best, alright? When you're free, please do the SPM module, alright? Anything not sure, can WhatsApp me, send me the question, send me your doubt lah, your anything you feel not sure or what lah. Okay. Okay, any other question? No more. No more, then wish you good luck. Okay, bye-bye. Thank you. Bye-bye. Thank you. Bye-bye. Thank you. Bye. Bye-bye. Bye-bye. Take care, everyone. Bye.
老师，
不客气。拜拜。
我那个
来，
这什么时候还是 directly proportional，什么时候还是 decreasing 零的零？
如果它是从零开始，就是 directly proportional 自己啊。如果它是这样子，它就是 increasing linearly。但它是这样子，它就是 decreasing linearly。linear 就是 straight line 的意思。OK，
哦，
还有问题吗？
没有啊。OK，谢谢。
谢谢大家。拜拜。